Welcome to today's Energy Central's webcast, entitled Optimizing Grid Flexibility and Resilience Through Digital Twins, Edge Compute and Communications.
Now I'd like to hand the floor over to Olivia Wink with Dell Technologies to kick off things for us today. Olivia, welcome to the event. You have the floor.
Thank you, PJ. Hi, everybody. Welcome. I'm very happy to be moderating today's Energy Central webinar, hosted in partnership with Dell Technologies and Scribe and Nokia. We're here today to explore a very hot topic, how utilities can optimize the energy grid for a more resilient, flexible, and sustainable future. So this conversation is grounded in a joint white paper that was developed by our three organizations. The paper outlines the critical technologies and strategies needed to modernize the grid, from edge computing and private networks to real-time orchestration. So we'll be diving into a handful of key topics today, starting with the shift to distributed energy resources, and then moving through the enabling technologies and business impacts. I'll be guiding the discussion with questions for our three wonderful panelists. Thank you guys for joining, and I'll have them introduce themselves now. Let's start with Tom at Dell.
Yeah, hi everyone. Thanks for joining us today. My name is Tom Ledoux. I'm part of the energy vertical at Dell, and I'm a solution architect that helps to put together all the different parts and pieces. As you may know, Dell has lots of different products, but how we put those together to solve a particular business solution takes a little bit of extra effort sometimes. So that's what I do. I started off life as a software developer and then moved into the infrastructure side, always around the energy industry. So a long history of putting these solutions together to really solve a business problem.
Thanks, Tom. Maybe we move on to Ken next.
Great, thanks, Olivia, and welcome everybody. Looking forward to this discussion. My name is Ken Rabideau. I am the energy segment leader for Nokia, and I primarily work on with my team any strategies that impact the energy industry from Nokia's solution perspective, similar to what Tom said that he does for Dell. I have also been in this industry for quite a long time. I have a carrier background and working with Sprint and a couple other carriers for many years before I moved into the energy industry, but I've been in the energy industry for over 25 years, so a lot of background as to how some of our solutions have evolved in this space.
Thanks, Ken. And lastly, we have Stavros.
Thanks, Olivia. So hi, everyone. Thanks for joining. Look, pleasure to meet you all. So my name is Stavros Zanis, and I'm really excited to be representing Inscribe today. So Inscribe is a Nokia venture that's been set up to focus on digital twins and real-time orchestration of distributed flexibility, which is one of the topics we'll be going into today. So just quickly, my kind of background. So I'm an energy guy. I've got 20 years in the energy industry. My focus has been on commercializing new tech, particularly in distributed energy. So prior to Nokia, I spent 15 years at Centrica, which is the UK's largest energy and services company. So yeah, don't be fooled by my accent though. I'm now based just outside of Philly, so I've been here for 8 years. Absolutely love it. So yeah, look, I joined Inscribe a year ago to do what I love doing best, and that's commercializing new and exciting energy tech, which is exactly what we're doing. So yeah, it's a pleasure to be working closely with our partners Dell and Tom and his colleagues, and our parent company Nokia, Ken and his colleagues. So yeah, that's me. Back to Olivia.
Wonderful. Thank you, guys. It's been really lovely prepping for this webinar together. It's a good crew. So last thing is our audience. We've got some space. If you guys want to ask any questions throughout the session as well, feel free to engage via the Q&A feature. That's all for intro, so we can jump right in. I'd like to start with the bigger picture. As we know, the energy grid is undergoing a fundamental transformation from a traditional centralized system to decentralized distributed energy resources. So for my first question, it's for all of the panelists. What does a resilient and flexible energy grid look like in the year 2030, and what role does your company play in achieving that vision?
Maybe I'll go first, Olivia, It's
Thanks, Ken.
I think that in full transparency, I don't think we know 100% what all applications we're going to need in 2030 yet. I think we have a good framework that probably Stavros and Tom will talk about for what we're going to need to deliver safe, reliable power for the future. Utilities have always been good about adopting applications to drive the grid. They've been doing it for 100 years. I have no doubt that some of the disruptive trends we're going to see going forward, data center growth is one of them. The EV adoption or energy transition is another one. Even cryptocurrency usage is something that's driving the power companies to change the way that they meet customer demand, right? So I think at Nokia, we're helping energy companies be successful in building a resilient grid that can adapt to those changing conditions and even any climate related conditions with modern communications and software to improve their monitoring, security, and resiliency.
Yeah, so maybe Ken, maybe I'll add to that. So I think energy grid in 2030 is not that far away, I think is one thing. So like if we look at the kind of last decade, I agree with kind of Ken, you've got this load growth that's happened, particularly in the electrification of heat and transport. But I think like that was pretty much predicted. It was driven by, policy sustainability objectives. I don't think anyone really expected, the dramatic load growth from data centers, particularly driven by AI. I think it caught everyone a little bit kind of by surprise. So I suppose looking to 2030, for me, I see electrification of heat and transport continue to boom, not necessarily because of sustainability. Like in my view, they're just better products, full stop, these days. I think 2030, we're also going to see more electrification, particularly in the C&I sector, drones, robotics, heavy industry, etc. So yeah, like I agree with kind of Ken's view there. And like from an Inscribe perspective, I think the part we can play is to help to manage some of the impacts of that explosive load growth. Particularly in a world where you've got volatile weather-driven renewables and generation. So I think we're really going to have to unlock the demand side and flexibility. And where I see Inscribe helping in 2030 and beyond is, utilities, large C&I customers using platforms like Inscribe. So we're a software platform to create digital twin simulations of their distributed energy systems, their ecosystems, modeling the impact, and then using software to deploy, strategies, flexibility strategies in real time. So yeah, that's kind of my view on 2030. Totally simple.
Yeah, and just from a high level, I mean, the energy distribution grid that's been around for the last, 80, 90 years was designed to go one direction, right? From the power generation down to the consumption, down to the houses or the buildings. But what we've seen over the last 5, 6 years is it's changing dramatically because we've got all these new energy resources coming into the grid, and there's got to be a lot more feedback and communication going both directions. And that requires, like Stavros said, a huge amount of flexibility. And you've got to make this change in real time without any disruption to the current grid as it is. And that's a huge technology problem, which is why we've seen that convergence of IT and OT come into the energy utility grid sector, because there's a big change coming, and it needs to happen very quickly and take in all these different data sources.
Thank you, guys. I've got one more question for all of you before I start picking on you individually. How do you see the collaboration between compute, communication, and orchestration evolving in the energy sector?
Maybe we could jump to the next slide, because if I go first again for the panelists, I think probably this slide means that utilities are going to get access to more tools. They're going to be able to take advantage of some of the buzzwords like digital twin, augmentation to help you do your job, whether it's augmented training or personal protective equipment, or whether it is massive amounts of sensors that give you a better picture of what's happening real time, or even robotic operation. We've already seen lots of our customers ask us for communication for robots to monitor transformers in a substation, or drones to be able to do vegetation management. So adoption of a lot of these tools that help you with either safety, productivity, or efficiency are going to be where we see the collaboration. You know, a lot of these applications can be run at the edge, as I think we'll talk about. The digital twin piece is one of the staples of this paper, which is, you know, modeling an asset that exists physically to see what you can do later. And I think that you can look forward to being able to build these tools on top of the modern architectures.
Yeah, and just real quickly, the reality is these computing environments are all going to be distributed over long distances. And whether you're collecting the data locally, computing, running AI locally, or back in the data center, that communication back to where the actions need to happen is extremely important. So that's where, you know, it's not just about computing in one place. It's about making sure that everybody who needs access to that data to make the right decisions from even a safety perspective has all that information available to them at the quickest possible time. So all those things have to fit together, along with all the regulatory requirements of, you know, how long do I have to keep the data? How long do I need to use it for? When can I make better decisions based on historical data? All that has to work together in order to provide an efficient operation.
Yeah, and maybe to add to that, Olivia, I like the way you kind of put the question, you know, compute, communication orchestration. I kind of see it working exactly like that. Like I use the word a lot, an ecosystem. I don't think we'll see a silver bullet. I think we need to see a collaborative ecosystem of all three elements. And, you know, reliable orchestration, which is one of the topics we've been talking about, like, it depends on secure and scalable communications. And from the perspective of the orchestrator, you know, and Scribe, you know, we think it's critical that our platforms, you know, able to be deployed across communication networks, whether it be cloud, on premises, local, remote. So it needs to be deployed within that ecosystem. And the way we've kind of designed our platform is, you know, we can deploy virtual orchestration nodes across a variety of hardware. You know, we're working with Tom and his our friends, his colleagues at Dell, to deploy the Scribe orchestrator on their Dell PowerEdge server. So yeah, like working as an ecosystem, compute, communication, orchestration, definitely working as one.
Yeah. So moving from how we're working together and kind of this big picture and thoughts of the future, I want to now focus in on edge computing and real-time orchestration. So edge computing is transforming how utilities are operating in real time. And I'd like to talk about how each of us are enabling smarter decision-making at the edge. So Stavros, I'd like to start with you. What makes orchestration the ideal edge application for utilities, and how does Nscribe's solution address this need?
Thanks, Olivia. So I'm a bit biased on this one. So I'd say orchestration is the ideal edge application, right? It's a key application which allows you to directly align grid physics, you know, with business objectives in real time. So in Scribe, we build orchestration nodes. These are virtual nodes, and they operate at the edge. So these nodes optimize DER behavior in real time while respecting grid constraints. So the benefit of edge computing in all of this is that it allows decisions to be made locally, you know, reducing latency, improving responsiveness, etc., and enabling that kind of decentralized intelligence. So, like I say, it is an ideal edge application, but I think it is important to look at, you know, some of the points my colleagues made on, you know, the utility needs. The utilities are going through like some major challenges right now. You know, the centralized to decentralized grid, massive growth of DERs, massive growth of load, resiliency challenges, all in the background where I think it's likely impossible to build and reinforce the grid fast enough to deal with that. So like I see orchestration of DER Flex as, it's not just an ideal application. I do see it as becoming a critical edge application for utilities.
Thank you. I agree. Moving to Dell, can you elaborate on how Dell's edge infrastructure is supporting real-time grid operations?
Yeah, the thing that's happening at the edge is there's a lot of new, not only sensors like Ken was talking about, but new operations. So for a long time, the edge had kind of like purpose-built functions. You had a separate system just for doing video. You had one system that managed taking data, some data in, and then you had another one just for doing the communications. But what we've seen now is that we're adding so many new functions so quickly. The edge really needs to be um, more of a general purpose compute environment, because we're going to quickly change what's happening, what's coming in, being able to add new functions very quickly, but without having to go out to 1,000 different locations and install a new device. If we're going to really make this edge environment and the edge computing really solve business problems, the technology needs to be flexible enough to increase and add new functions to it. And so that's where that whole software-defined infrastructure comes in, so that we can add new technology, still maintain the data, but really solve a business problem and take care of compliance issues too. Because again, the government does like to monitor and make sure that things happen properly. So we got to make sure we capture all that data. But from a real-time perspective, we work with our partners such as Broadcom and even on the Linux side, KVM. They have actual real-time kernels that we've kind of certified for our hardware to make sure that when we need real-time operations, and not everything at the edge needs to be 100% real-time, but we also need to make timestamps within there. But for the ones that do need real-time operations, we can actually satisfy those with generic hardware, but with real-time kernels that really take the timestamps in and make sure that everything happens correctly. But there's so much data that's currently being developed and brought in at the edge, and there's going to be a bunch more over the next few years as well.
Thanks, Tom. Ken, I'll move to you for my last one. What role does communication infrastructure play in enabling real-time orchestration at the edge? And how does real-time orchestration at the edge empower utilities to make smarter and faster decisions?
Yeah, I think that when you're looking to achieve better SLAs occasionally than what you can get in a public network, maybe you need 5 or 6 nines instead of 3 nines of reliability. Maybe you need latency sensitive applications to have tighter constraints that they run inside. Maybe you need better access to the layers of security that you need to build. I think that you get pretty good tools available today in the public networks from the cloud providers, from the different carriers that are out there. But for a lot of the OT environments that our utilities work in, we still see them tending to prefer private networks for those best practices on network design for better SLAs for their internal applications that they're trying to deliver.
So none of this works without robust communication. I think for our next topic, I want to turn to the role of private networks and standards like IEC 61850 in enabling secure and scalable grid operations. And Ken, I'll pick on you first for this one. Can you explain the significance of IEC 61850 and how Nokia is supporting its implementation in modern grid communications?
Yes, I think that is a good lead-in from what Tom was talking about earlier when he was talking about the needs for utilities going forward are flexible. You need to adapt to the changing loads and the increasing pressures of being able to deliver new applications that, quite frankly, we hadn't even thought of 5 or 6 years ago. And digital twins is one of those. The automation, the severe automation that we're seeing, and being able to respond more rapidly to outages in the network. Those are 3 different areas. And luckily, when you're talking about flexibility and modern architectures, IEC 61850 has already built a mature framework for substation automation. Its primary benefit was to be flexible to modernize energy systems, and its ability to unify all the various different communications protocols, the interaction between different types of equipment, such as protection and control or measurement devices, is critical. So when you look at the edge compute piece in this slide, you can see that just changing to digital isn't where we stop. You have a lot of utilities now are looking at edge compute in a hybrid environment, moving from just pure digital to virtualized or containerized, and then eventually into full virtualization or containerized. The standards have already been working on adopting those, like IEC 61850. NERC has also been working on virtualization and where it can benefit. It actually adds a good bit of resiliency to go towards virtualization. Once again, as I mentioned before, you get better tools. So we see IEC 61850, since it's been mature, it's been pretty well vetted, and it has the ability to expand with these changing needs that we didn't envision, are probably good reasons to look at it if you're not already doing it.
Yeah, thank you, Ken. So Stavros, moving to Nscribe's orchestration approach, how are you guys adapting to different communication environments and grid topologies?
Yeah, so there's a little bit going on this slide, but let me start with our platform. So, our Nscribe platform's been designed, from first principles, from the edge up. That's how we've thought about it. We built it actually on top of some technology developed at Nokia Bell Labs called worldwide streams. So that particular technology allows you to process and optimize streaming data, hence why it's a fantastic application at the edge. And look, power flows across a grid, across a distributed energy system are an ideal application for streaming data. So what we're kind of showing in this diagram, like we're trying to enable an evolution to a real-time orchestration grid overlay. So we implement orchestration of flexibility by deploying distributed orchestration compute nodes. We can do that flexibly across any kind of distributed energy system. So whether it's a distributed distribution network, grid, community, or even a virtual power plant, and virtualizing all of it. And we can deploy these across any type of comms network and grid topology. So you can see, in the diagram here, we've got a mix of private and public edge clouds, on-prem hosts, all creating one, virtual optimized orchestration. So another point I'd add actually is we are completely asset and hardware agnostic. So open standards are useful. When we're trying to be completely agnostic, so we can deploy our nodes across any kind of DER asset or comms controller, etc., and really optimize across balancing cost savings, revenue, resilience, etc., and solving distributed optimization problems in a distributed way, which we think is kind of quite unique. So I suppose we're adaptable to comms and grid topologies by design.
I like this visual a lot, thinking about that first slide we brought up about a disrupted grid and looking at all of these new distributed assets. Tom, I'll ask one more question regarding the Dell side and the native edge software. How does that software integrate with this communication infrastructure to support all of these distributed assets?
Yeah, thanks, Olivia. Yeah, so I love how everybody's talking about orchestration, because that is really the hard problem at the edge, because there's so many different devices that need to be placed throughout the environment. And most people know Dell as a hardware company, right? They know us as we provide servers, we provide laptops, we provide even monitors for a lot of different situations. But Dell also has a very large software division where we're writing software to, again, make the infrastructure easier. And one of those is the Dell Native Edge Orchestrator. And again, it's a different level of orchestration than what Stavros was just talking about. We're now taking all those different hardware and computing devices. We already said we need a lot of different types, whether it's from a full server to a very, very small, low power device that's just doing data telemetry. But the reality is the energy grid and everything associated with it is also under attack. whether it's a physical attack, we've seen people drive cars into substations, or whether it's a cyber attack. And so if we're going to be able to put more compute, put more sensors out there, we've got to find a way to make it simpler to actually stand up those devices. And so what Dell has done is actually written a lot of software to provide that zero-touch provisioning. So you don't want your solar panel expert or somebody who's working on batteries to have to be an IT person. You want them to just be able to do the very basic, which is just plug in the device, make sure it has power, get it connected to a network, and from there, it's all hands off. And so that's what the Native Edge Orchestrator does. It's able to identify a new piece of hardware, allow it to go into the system management console back in the data center, and now I can provision it, whether it's securing it from the data that it's pulling up to actually taking what's called blueprints. These are software packages, applications, or containers from the partners like Inscribe, and ensuring that their software doesn't get manipulated in any way, and we can push those out to all the different devices. And that does a couple of different things. Number one, it lets you control exactly what software is running there, but it also lets you control the version of the software, right? And again, we're going to have thousands of these devices. We can't send somebody out to every single location just to update a piece of software or to do an update to the firmware. We want that all to be controlled internally. So the lifecycle management, the fleet management, even the blueprints all happen back at the data center, but can be controlled throughout all these environments. You can also set up location-based stuff. So now I can say, if this server dies, the nearest neighbor is right here, so he'll take over for that server should something go wrong. So there's a whole level of infrastructure orchestration that needs to happen to simplify what's going to be happening at the edge as we grow all these devices that are happening and changing to the grid.
Let's stick with energy orchestration for a little bit longer, specifically looking at Inscribe's role. So Inscribe has developed a unique approach to real-time multi-objective control. And I'd like to learn a little bit more about how their orchestration nodes and simulator are helping utilities plan and execute smarter strategies. So Stavros, this one's for you. Can you walk us through how the Inscribe simulator is helping utilities plan and validate orchestration strategies before deployment?
Yeah, thanks, Olivia. If you don't mind, if it's throw up slide 13, and I'll do a bit of a walk.
Who's on it?
We might need the visual for this one, so I'll be patient. Okay, awesome. Thank you very much. So yeah, I'll kind of do a bit of a walkthrough of this slide. So if we go left to right here, so on the left we have our user interface. So Inscribe, we are a software platform. So our ambition is to distill the complexities of flexibility into user-friendly software, a bit like Tom was talking about. Right? We don't want every single user to have to be the most highly trained optimization scientist in the organization. So we're building software. So we've got the user interface on the left. So using the user interface, our customers who are utilities or prosumers, C&I customers, etc., or solution providers. So through the UI, our users can access the Inscribe platform capabilities. And we've kind of built two capabilities, core capabilities on top of our technology. And both of them work hand in hand. So the first capability is digital twin simulation. As you can see, there's a bit of a virtuous circle here that works hand in hand with optimized orchestration. So we see our customers and our platform users using this tool to walk through really a four-step process. So step one in the process is to digest resource data. So to create a digital twin model of a distributed energy system. So that can be asset data, asset parameters, so whether it's a DER, a battery, a solar system, etc. You can ingest weather data, market data, or other financial data and parameters. So it's really building your techno-economic model. That data can be either historic, you can feed predictive or forecasts if you have them, or as we move into real-time operation, we can actually ingest streaming data at the edge. So step one is to build the digital twin. Step 2 is to build a digital twin simulation. So discovering flexibility possibilities through simulations, so variant comparisons. So for example, we've got optimization in there for battery size, battery cycles, degradation modeling, etc. So you can really explore quite detailed variants of how you might use the flexibility in the system, in the digital twin of the DER system you've just set up. Step 3, once you as the operator, as a decision maker, are happy with the way you've simulated your distributed energy system, you then deploy that. So the platform allows you to deploy those optimal configurations through hybrid edge intelligence, so deploying through the orchestration nodes that I talked about earlier, yes, to bring that digital twin strategy to life. And then number 4, which I suppose is most important, is steering those assets and devices in real life according to the digital twin techno-economic model. So automating that asset behavior and steering in real time. So that's kind of the 4-step process that that our users of our platform can use to translate digital twins decision making into reality. And what that allows you to do, on the very right hand side, we allow our user to set multi-objectives. So you can set objectives at asset level, portfolio level, etc. But most commonly, you're going to be using flexibility to pull financial levers. So in this way, you can really optimize your value stack. And I've listed, we cover international, so these are quite generic terms, but you can balance across energy markets, balancing markets, ancillary services, and DR programs. So you can really value stack not just, for example, battery, but your portfolio. And you can unlock, some of the behind the meter benefits. So for example, self-consumption of solar in gross metering markets, etc. So ultimately, our tool can help utilities by enabling, real-time data streaming, optimization for flexibility, and balancing from the edge up. So that's kind of a nutshell how our platform works and how our users would experience it.
Thank you, Stavros, for walking us through that Nscribe simulator. So now I'll pick on Tom and Ken. Let's move into the technology backbone that's supporting the simulator. So Dell and Nokia have made significant contributions from the Dell ruggedized edge servers to the mission critical private networks with Nokia. So Ken, let's start with Nokia's private network architecture. How is it enhancing grid reliability and security?
Thanks, Olivia. Yeah, I think that when you look, one of the things that I was trying to do, I was trying to figure out how to simplify all the things, all the layers that have to get built in order to support an electrical grid. And I figured everybody understands Legos, so I call this a Lego slide. You can snap pieces together as you want to or you need to create the network features and the transport properties that you would like to have. And all of that goes to what I was speaking to earlier, and what Tom pointed out was, having a flexible enough network to deliver the use case or application you want, even if it's for edge compute, and then be able to deliver the security, the extra security or the extra SLAs, like say lower latency or bandwidth monitoring on demand, something like that. Or it could be, just that you want a deeper level of encryption that's available in a public network venue. That is where this adaptive fabric that we've kind of put together kind of goes hand in hand. It's interesting. I was looking at a couple of the questions that were in the queue. One of the questions was around encrypting things like voice traffic. If you look at this particular slide, there's lots of ways that you could do for encryption. If you look at the access devices that are coming in, you could use multi-factor authentication on those devices before they communicate over VoIP. You can also segment the traffic using either the software-defined networking layer or the services MPLS layer, or even the transport layer. All of those have different encryption tunnels where you can segment traffic and you can provide different encryption. One of the other questions, also encryption related, that probably we could talk about on this slide was around post-quantum encryption or post-quantum computing that you need to be ready. So a lot of the work, for example, that Nokia has done recently has been around making sure that our networks are already post-quantum ready or post-quantum enabled, so you can do things like symmetrical encryption across the segments that you're building, or you can build other components to make sure that the communications is going to be post-quantum qualified, I guess would be the best way to look at it. We use the kind of the NIST finalized standards, or the standards that they've been adopting to be able to address those. But being able to apply those NIST recommendations across the different layers in the network for your encryption, I think those are ways that we can also address how to keep your deep connectivity available, and also make sure that we can be flexible enough to support applications that you don't even know you need yet.
There you go. Ken, thank you for answering some of the questions in the chat as well. I appreciate all of the audience members who are chiming in and adding some questions as we talk. And we'll try to incorporate them as we keep moving forward. Tom, my next one's for you. How is Dell addressing the energy efficiency and sustainability of its edge compute solutions in harsh environments?
Yeah, so again, as we expand the edge and start adding more compute to it, you can take a standard server and take a laptop and put it out the edge. But the reality is there's so many more environmental things going on there that don't happen in the normal data center, right? So things like dust, various temperature changes, humidity changes, all those things are more important to look at and be ready for at the edge than they are in the data center. So not trying to get into a sales pitch, but Dell has a complete product line built for the ruggedized edge. It's called our XR series. And we always put those through all of the different certifications, whether it's mil-spec NEBs for telecommunications, and of course IEC 61850. There's a part of IEC 61850 that covers environmental, shock, temperature, and for most of our XR servers, we do get that certification. And let me tell you, that's a long process. It's a very expensive process to get through that. But that's how serious we take the edge computing. And so we've put those servers through there to make sure that they're capable at the edge. But again, we've also written a lot of software, things like Power Manager, where I can look at my edge servers and I can see if one is taking up way more power than it should. I can actually calculate my carbon footprint for the computing environment and make sure that my edge operations, again, fit into the business model or the sustainability requirements that the company may have in its reporting. So all those things fit together, both with the server and the software infrastructure managing that. And again, the thing that's really going to be changing over the next few years is that ability to do more AI and agentic operations at the edge, right? So we'll train the AI models back in the data center and then push the inferencing out to the edge. So having an edge-based server that can have a GPU to accelerate those real-time decisions that need to be made autonomously or through agents is extremely important. So some of the servers that we have can actually take GPUs today and still meet the dust, the certifications, the temperature changes, the temperature ranges that is needed at the edge. It's a very difficult problem to solve, but working with our partners, we're providing both the hardware and the software to solve those problems.
Thank you, Tom. So now that I've picked on each of you individually, we can wrap up, kind of taking a step back again and looking at business impact and use cases. So let's talk about the real world impacts of all of these technologies. And I'll pose this to the panel. What metrics should utilities look at to measure the success of edge and orchestration deployments?
I'll let Ken go first on that one.
It's a tricky one. Yeah, well, I second that.
Well, so remember, my expertise is in the communications to support the applications that you're trying to run. So Most of the time, what you're looking at is if I build a service across the network and I want to connect any application. So let's just say it's SCADA or it's DERMS or ADMS. Then I want to make sure that whatever the requirements for those applications, whether the service needs to be encrypted, whether I need a certain latency, whether I need a minimum bandwidth or I need to expand to that bandwidth, that those are going to be available for the way the service is defined in the network. So one of the topics we've been talking about so far has been the automation. So when you're designing your automation, make sure you know at Nokia, we call it the intent of the application that you're deploying, whether it's on an edge compute device or whether it's in a central location. And then make sure that the network service that you're building is going to meet the work or the business intent that your internal organizations need to deploy the application. And that will give you the measurement pieces that you need to look at. Am I meeting an uptime SLA? Am I meeting a resiliency 5 nines or 6 nines? Am I going to meet a latency piece? Those are all the SLAs that are defined based on the intent for the application you're delivering. That was a long-winded way to say that. No.
Thanks for leading the charge, though, Ken.
Okay, I've got a short answer and a long answer, so I'll have a go at both. I suppose short answer from an energy perspective, like orchestration, it just needs to deliver secure, reliable, economic flexibility to the network, to the energy system within user boundary conditions. Right, that would be my kind of very short answer, but I've got a longer one, so I'm going to have a crack at it. So I suppose the first time I ever worked with a grid operator was back in 2011. I was working on the largest smart grid project in the UK at the time. So £54 million grant funded project, 14,000 very willing homes and businesses trialing some really early stage demand response and direct control, EVs, heat pumps, etc. So this was a while ago. It's relatively ancient history when we're kind of looking at today's world of real-time orchestration. But what kind of struck me, and it stuck with me on that project, was the measure of success that the UK regulator was trying to incentivize. And that was the ability for any alternative smart solution that the network operator deployed to either defer or avoid network reinforcement. So equivalent to putting copper in the ground. And it strikes me as, today in tomorrow's world of, hyper load growth, faster than we ever expected, cheap weather-driven renewables, and sometimes, abundant energy, and a grid infrastructure racing to catch up. I feel it's kind of more important now than ever for the value of flexibility, especially edge orchestration, to be unlocked. So I think using intelligent solutions like orchestration of DERs to defer or avoid network reinforcement, particularly at this kind of, really challenging time with growth in the system, I think that's really important. And ultimately, if we can reduce system costs and transfer that value to the end consumers and give people cheaper bills, for me, that's the kind of ultimate measure is consumers can have their energy cheaper and more reliably. So that's kind of my short and long answer there.
Thank you, Stavros.
Yeah, I'm not sure there's a lot I can add to what Stavros and Ken already said. The one thing I would say to utilities is that, don't be afraid to move faster, right? And reach out to your technology partners, because we've all been looking at this problem. We've all been working on solutions to help solve it both securely and simply, right? Because security and simplicity is going to go a long way to helping you move forward, to modernize the grid and add these new operations to it. So we're here to help. But don't be afraid to pose some tough questions to us.
Hopefully we're not too scary of a bunch. I think we seem pretty approachable if anybody has any more questions. So before we move into any additional audience Q&A, it would be great to end with one final thought. Looking ahead, what's one thing that utilities should prioritize to accelerate their journey towards a modern, resilient grid? This is for all of you guys, just kind of sharing a final thought and a note to the audience. If you guys have any questions that you'd like to ask, we'll move into Q&A after this, after sharing these final thoughts.
You know, maybe I'll jump in here. It's tough to underestimate something simple like evaluating your skills and resources that you have available when you do any of these modernizations or build automations. It really does take some time to get people educated. You can rely on vendors to share their best practices and things that they've learned while implementing with customers, but training your people in order to be able to, it's good to do pilots, but once you scale, there's always extra issues with scaling. So I think that skill sets and resources, along with scaling lessons learned, are probably two things that I would say to not ignore while you're looking at all the cool stuff like the technology and the AI and the buzzwords.
Stavros, Tom, any final thoughts?
No, I thought Ken covered it very well.
Yeah, no, I mean, I suppose just final thought. You've got the kind of slide up. It's it's fantastic for us to be able to collaborate with our partners Dell and our parent company Nokia. I think like there's a fantastic combination of capabilities here that can deliver some real difference to utilities and ultimately the end customer. So yeah, I mean, I've just it stuck with me. I didn't make the comment on Tom's kind of presentation on the ruggedized edge servers. I mentioned there's a massive load growth and flexibility potential in industrials, and a lot of the customers we're working at the moment are industrials. I was thinking about mining, right? You think of the challenge of electrifying mining. It's not as kind of simple, and I don't mean to sound belittling, but it's not like a thermostat on a wall in a home, right? You're going into quite challenging environments, and to deliver that flexibility in kind of mission critical environments it's going to take collaboration. So yeah, it's fantastic to work with our partners on this.
Thank you. I agree. I feel the same way. Okay, let's move into some audience Q&A. I've got a question that I'll pose to you, Stavros, first. A question on the domain aspects of Nscribe's digital twin models. So someone in the audience is asking, does it include all the relevant grid codes, and how do you handle code updates?
Yeah, it's a great question. I suppose I will start the answer on this by saying we're a relatively early stage venture. We're a venture within Nokia. We're trying to kind of develop cutting edge technology, and I go back to the way we've set up the platform. So we are at a stage where we're just commercializing this. So the simulator capabilities are live. So we're deploying those with customers across the world, actually, from battery EPCs. We're working with some of Nokia's telco customers, and as I said, in mining as well. So we're a relatively early stage. So we have the simulator up and live. It's commercial. In terms of deploying the digital twins into orchestration, that is under development right now. So, fantastic point, making sure that we're up to date with grid codes. That's certainly something we'll be looking at as we deploy this in the field. But right now we haven't got a live deployment in the field. We are, we've got some of Dell's Power Edge servers up and running with the orchestrator, but we're really taking our customers through a journey right now from the simulator through to orchestration.
Another question from the audience. Do you see blockchain technology playing any role in the value of edge computing and distributed resources?
Yeah, Olivia, I guess probably all of us have a perspective on that, but I would say we get asked that question on a regular basis just because there's so much blockchain usage, like in cryptocurrencies and everything. But, beyond that, if you bring that down to the power company level, power companies could use it for peer-to-peer energy trading, could enable, direct transactions between like energy producers and probably sophisticated consumers. From a Nokia perspective, we see it in either improved security or maybe improve transparency, because a lot of times what we're looking at with our customers is how to secure system of record information or log information, so that if you need to produce information or provide some extra transparency either to regulators or to your own internal management, blockchain could be used in that secure manner. So I would say probably for me, the two top ones that come to mind would be like peer-to-peer energy trading, and probably security in the grid.
Yeah, I'd say,
Yeah,
sorry, go on, Tom.
No, I was just going to say, yeah, and again, the most electric utilities in different countries are regulated, right? So the immutability of that data, if you store it in a blockchain where it can't be changed once the hash is created, that's going to be really important with all the new data that's coming in through these edge devices and edge applications. That ability to make sure that you follow the governance and make sure that the data doesn't change over time is going to be extremely important. So I think there's definitely a big use for it. And again, it comes down to how different applications use different data types.
Yeah, maybe add like the distributed ledger type technologies are fantastic and do have applications in energy. I mean, from what I've seen, some of the evolving DSO markets, particularly in the UK and Europe, are starting to use blockchain technology in their backends. So I think the technology certainly has its place. Energy is all about transactions, and that's why that technology is particularly powerful. In the Inscribe platform specifically, so we see ourselves interacting and interfacing with markets and being that bridge between the device and the market itself. And in an ideal world, we want to do this in near real time with streaming optimization. So it probably won't use it directly in our platform, but certainly can see our platform interfacing with blockchain enabled energy markets, flexibility markets, some of the new DSO markets. But great question, really fascinating topic.
I think maybe we wrap up soon. I'm seeing if there are any additional questions in the chat that we didn't cover. Let's see. Okay, I think we've got time for one more if you guys are up for it. We got a question earlier. Are you digitally signing your network for more updates with the ability to be PQC ready for 2030? I assume with focusing on what considered critical infrastructure 2030 is US and EU timeframe, in the US and EU timeframe, with others lagging somewhat. Sorry, I feel like I read that in a funny way. I think they're asking, are you digitally signing your network firmware updates with the ability to be PQC ready for 2030 is the question I'll focus on.
Yeah, maybe I'll go first. I talked a little bit about PQC earlier when I was talking about the adaptive network slide. I was really focusing on the encryption there, but I think that the standards are still developing. We are trying to make our update process as secure as possible. I think what you'll see is that the more and more updates to, especially to critical pieces of software that get deployed automatically over the network when automation is in place, will be let's just say PDC compliant. I think, like I said before, we're kind of focusing on some of the NIST work and best practices that they've done, but there's other work in for example, the EU that they've been doing. There's a couple of different methods to do that now. We're trying to figure out. We've been experimenting with all of them, to be honest, trying to figure out what the best method is to use. So hold steady on that one. You're going to see a lot more on it.
Thank you, Ken. Okay, guys, I'm going to close this out. Thank you to our audience for the questions that you put in the chat. I think we covered all of them. So thank you to the guys for answering those on the spot. And thank you for such an insightful discussion. I am so grateful for the audience that joined us today and for you three sharing all of your expertise. We've covered a lot, from the shift to distributed energy resources to the enabling technologies and business models that are helping shape the grid of the future. I know that Dell, Nscribe, and Nokia are very proud and happy to be working together to help utilities navigate this significant transformation. If you haven't already, I encourage all of you to download and read the full white paper that we wrote together for a deeper dive into today's topics. Thank you, Ken, Tom, and Stavros again. And I'll hand it back to you, PJ, for some last housekeeping.
Thank you, Olivia and panel. Fantastic conversation. Really appreciate your participation today. It looks like the audience absolutely agrees. For our audience, please take a moment to fill out our feedback survey. We certainly look at your feedback, and we do use it for future events. For everyone here at Energy Central, thank you so much for participating in our webinar, and we look forward to seeing you on a future event. This concludes today's presentation.